Thank you, Natalia. I see some old friends as panelists. I think we've all met before. I think Steve, we haven't hosted on a roundtable, but it's great to have you as well, Steve.
Thank you.
Great. So I think, like our fellow presenters discussed before, we are in a very exciting and interesting space here, right? And some of the things that in terms of overall semiconductor healthcare, this fascinating intersection combined with the need to be sustainable, green, etc. All of them coming together has created this, I would say, a super exciting industry space, which I think is at least in the top 5 percentile of all the tech innovations that we are watching. And what I will do is I have two separate sections, and I know we have about 50 minutes for us to discuss. So the first section is more for the audience to understand, each of us from a background perspective, and a little bit on the more of icebreaker questions. So maybe I'll start, Dilip, with yourself. Dilip, you have worked with some of the top players in this space, right? You've been with GE, and not just in the healthcare space, but beyond that, you've been the CTO with Wipro GE, and now you're back to Siemens Healthineers as an ED. So you spent about almost all your life in the healthcare space, more than 3 decades. One of the things that I would like to ask is, based on your perspective, two things, right? One, where do you see the future of healthcare headed? And two, on what are the 2-3 key trends that you see this future trying to get defined?
Great. Just one clarification, not 3 decades of healthcare, but quite some time with healthcare. I did work in other fields. Great questions on what is the outcome for the healthcare in the coming years, and what are the trends in healthcare. I was actually listening to Ram while the previous discussion was happening. Very interesting thoughts, and I would say one of the things that has been transforming in healthcare, if you look at it, back in 1978 at Alma-Ata, there was a declaration that was made when the World Health Conference met. And they said health for all by 2000. Year 2000 was a goal that was set for all the countries, all the healthcare organizations, making that healthcare will be affordable, accessible, and accurate by that time. And that goal, while it was set, and everyone thought it was a good goal. And if you look at it, come 2020, and when COVID hit the world, we realized how prepared and how badly we were equipped to handle a pandemic like that. And it also actually gave us an opportunity to look back. Is the industry investing enough? Is the government investing enough? Is government actually focusing enough on healthcare in everywhere in the world? And of course, priority changed. And a few things that I'm seeing, what has changed in the past. It was always an industry where it tried to really create accurate devices for detection. If you look at imaging devices or devices for clinical care, the focus was always about, how do I make an equipment which is better, which can be giving less errors and can get results better, so that your diagnosis is better and your treatment is more focused. And over the years, as the digital started progressing and digital started really getting the advantages of creating insights, the 3 things that I talked about, affordability, accessibility, and accuracy, the 4th dimension actually crept in, the 4th dimension of acumen. And how do you create acumen? And here is where it was not a device, one device that was giving insight about health of somebody, but it was multiple devices which need to be used. And it actually brings in one point. I'm always fascinated by something that always worked well for many people in the past. concept of family doctors, right? A concept of family doctors where the doctor knew exactly what goes wrong with a family or a person that he is treating, because he always was associated with that family from childhood. He knows how the child has grown, what's the history, what works, what doesn't work. So his historic data and his ability to understand, hey, this fever, he gets it always, it goes off in 3 days. Or for this fever, this particular diet works for him. So there was no need for him to really do too many tests, but his historic data was helping him. And that got missing in present day world where people started moving in different parts of the world. And it was always like you go to a new doctor. And here is where the digital data is going to change the world. And I was actually fascinated with one a concept of family doctor in China, where a family doctor is paid on a retention basis every year. They are paid X dollars, in Chinese yuan. And in fact, that will be paid at the end of the year. But if anyone gets sick, certain amount is deducted. If more people get sick in the family, the doctor doesn't get anything. So the doctor is incentivized to really keep the family healthy, not make them sick and treat them. Okay. I mean, that's a part of the thing that I'm going to talk about, which is going to be a changing trend.
Interesting.
Yeah.
Very interesting insight, Dilip. Yeah.
Absolutely. So the digital is going to change the world in a big way. And I think what's going to happen tomorrow, if you look at it, the government of India has also come up with a national digital health stack policy, where the data that is being generated for each patient is going to be available for a patient to manage it, but it's not going to just vanish. With the advancements in the cloud technology, with the data becoming far more cheaper, 20 years back, what the data used to cost, and today it's just unbelievable. And with those things, the data continues to be available, and using of the data to really drive insights is what is going to change the world. Right. Ram talked about digital twin, and that to me is something that is going to be a game changer. In fact, it's not just about doing the trials or clinical trials to be done on a patient, or an early test to be done on a patient, but that's also going to be used as a way of wellness management, not a disease management. I think for a healthcare to move towards a goal of health for all, the only way for us to manage it is through catching the disease early. That means wellness management is going to be a key. And that's the biggest trend. And few trends, if you can think about it, it's all about, the digital twin is one of the trends that's going to be, you will be hearing a lot. Today, Siemens Healthineers has developed a couple of digital twins on heart and liver. And the level of accuracy will get better over time. The second trend you will see is in terms of utilization of AI for various solutions that are going to be coming through aggregation of data, not just from imaging devices, but also from genomics, from your personal fitness management devices, your mobile data, data that is coming from Swiggy, for that matter. Everything is going to be aggregated, and that's going to provide you a lot more accurate assessment of how things are going for you, and ability to really manage health in the future is going to be based on that. So the trend is going to be towards movement on a cloud. All this data is going to reside there, but the control is going to be still with the patient.
Excellent. Thank you, Dilip. That was a very comprehensive answer, very insightful as well. I'll try to just try and capture the diversity that we have in our panel and move to Steve. Steve, you're part of one of the largest memory and storage chipset companies in the world. And one of the things that we've all noticed is how semiconductor is becoming extremely important across different types of industries, including healthcare and medicine. Plus, there is a huge demand in the usual consumer electronics space itself. And all of this combined with, semiconductor shortages that we have seen due to supply constraint, right? And so what do you believe is the key challenge that you've encountered at Micron or in general in the semiconductor space of the memory and storage chip space, basically? And also if you could shed some light as to how you went about addressing these challenges.
Well, I'll speak more in generalities. I've been in the industry I started in the industry in 1982 and predominantly worked for two companies, Intel Corporation for 32 years. And then I joined Micron 8 years ago. And that transformation was really because of the need that I saw that and that others in my field have seen in terms of how the explosion of data, and then how we need to manage that data, and we need to manage the computation of that data, going forward, and make sure that now, instead of where I started earlier, architectures were about moving data to compute. It was really moving compute closer to data. But now to your particular question, the answer is really it depends. I think what you've seen, or what we've seen, are it depends on on the company. The largest vendors, who have a greater amount of vertical integration, have extensive investments in capacity, large geographic distribution of manufacturing and supply chain, and pretty substantial buying power, have been able to, there's a level of resilience they achieved, and have responded well, as just about any companies in the industry, to some of the challenges. And I would say in the semiconductor industry, at least in the years I've been here, it's very cyclical, and especially in the memory and storage. So companies have developed, like ours, have developed a pretty well-honed capability to adapt quickly to different market trends. And so, where you can adjust your just-in-time supply chain, and then look out ahead when you see, and be able to kind of do a pretty good job of predicting where the market's going to be, and try to get ahead of the game in terms of being able to anticipate trends. The biggest challenge is, smaller companies, at least from what I see, that tend to rely on others for manufacturing, older process technologies, things, and where research and development hasn't been really happening for the last 5 to 10 years to the same level that it's been happening for the newest generation processes and technologies. And finding solutions for those, for finding alternate supply chain solutions, have been a challenge. For example, just about every controller device has what they call a power management chip. And in a lot of cases, those chips are very old technology, and been around for some time. And as vendors are looking at those, the factory capacity winding down, and they turn around and say, okay, we need to potentially cancel that chip. Companies have been scrambling, ours as well, scrambling to find alternative solutions. So those are the real key areas that I think as an industry we need to focus on, because there is a lot of older capability that everybody uses, and we need to kind of modernize that, and learn from the lessons of the larger companies in terms of how they've been able to react to the supply chain constraints that have been occurring today.
Interesting. Thank you, Steve. That was very insightful. I would now like to bring in Mustafa, primarily because I think even from our last discussion, we saw that, Mustafa, you work for Microsoft, but it's an area which Microsoft is not really well known, right? So in the silicon part of Microsoft, and you've been doing it for a long time. And right now, we are seeing a massive shift, like I was discussing with Steve, in terms of almost every industry demanding silicon and silicon technology. In your perspective, and again, from not being part of, say, an end consumer industry or a silicon manufacturer, what is your perspective as to why there is the spike in demand for silicon? And not just maybe the cyclicality that Steve mentioned, but almost a democratic increase across the board in terms of demand.
Got it. Thanks for that. And Hello, everyone. So like Steve, I've also been at two companies. So I grew up at Xilinx, so in the semi industry, and I was a little surprised myself to find myself at Microsoft, which I did not associate with semiconductor and hardware. But coming in, I've gotten an appreciation for, we've been closely partnering with the semiconductor industry from the get-go, from the early days, from DOS, which was the origin. It's always been a partnership with semis. And over the past 20 years, we have started doing more design as well. So the Xbox silicon chip, for example, the front-end design was always done internally, then the HoloLens chip, and then so on and so forth. To your question now, right, like we've seen the cycles of horizontal versus vertical alignment, and the industry has gone through that many times, right? So we had the the pre-Windows Intel era where everything was sort of vertically aligned, and the same company packaged all the layers, and then those layers got split into horizontal alignment. And every time there's a form factor or some kind of demand shift which pushes on that horizontal alignment, there's experimentation in going more vertically aligned to exploit differentiation that is not otherwise possible. So for example, the smartphones pushed on that as you needed more accelerators packaged in to meet a certain power performance envelope that you could not get in that form factor from off the market parts, and sort of that pushed in that chip. Likewise for things like HoloLens, right? When we need a certain type of very optimized performance at a certain power point, we went and did that design. Cloud is also pushing on that. The first generations of cloud were all built on off-the-market server, network, comm, storage infrastructure. But that's not how the cloud of the future will look like, right? You can't have an optimal cloud with millions and millions of nodes and exabytes and thousands and millions of exabytes of data built on traditional style server architecture. So innovation will happen. That innovation is happening across the semiconductor industry, and we partner with the industry, and some of the innovation will happen within the company. So I think that those are just some examples of what drives companies to do vertical alignment, and that's just a pattern that will keep repeating itself, I think.
Excellent. Thank you, Mustafa. Gilroy, you had like significant experience working with different types of customers and industries, at the same time being associated very strongly with the semiconductor as a horizontal, right? And that's why I wanted to bring you towards the end to kind of tie up all the different things that we've heard. So from your perspective, Gilroy, how have you seen this shift in not just the appreciation for semiconductor in industries, especially in industries such as telecom and automotive and many of these other industries which typically were never associated with being significant semicon consumers?
Sure. Thank you, Siddhant, for the question, and good morning, good afternoon, and good evening to all of you. Again, I've been fortunate to be part of the company from the beginning, UST, right? I mean, this is my 22nd year. I was fortunate to be part of the first customer of UST, which was brick and mortar, was one of the largest retail customer in the US, right? So that is where we were doing all the application development, legacy system management, and all of those. We got into semiconductor in the 2009 era. That's the time when UST got into semiconductor. Until then, we were pretty much doing the software part of it. Now, getting into semicon, we knew that obviously we need to start with all the conventional things, with the pre-silicon, post-silicon, embedded, and you name it, right? But the turning point for us was that with all the different vertical customers that we have, which are the Fortune 500 customers that we serve, they always came up with problem statements. And we looked at, as one of the panelist member mentioned about, right? How do you see the horizontal vertical alignment of the expertise that we bring in semicon tying to the problem statement of a retail customer was a turning point. for the semiconductor engineering unit of UST. Now, where is that proof was in the pudding? I think everyone can talk about that way. But what really excited all of us was we created an experience called frictionless commerce. And what that frictionless commerce means, it's like you walk into a store with a mobile app, you have a QR code, you show the QR code, you walk into the retail shop, you pick up all the stuff that you want, you walk out, you get the receipt on your phone, and you're done, right? We were able to do that as an end-to-end engineering capability, which includes all the technologies that Kingsley was talking about. From the silicon side to getting the chip design done, to cloud, to the AI algorithm, the sensors, the wave balancing, the video analytics using the computer vision technology, and then obviously the app, right? All of those came together to make that solution happen. And that is where I think the excitement for us as a company, where we started doing a lot more. It's not only for retail, we could do the similar things for other verticals also. I know Dilip and Ram were talking about so many use cases on healthcare. We also do a lot of medical devices, things for various other customers. So all these ties back to how can we bring in technology to solve a problem as an end-to-end engineering? Gone are the days when you think about, okay, can we have somebody only to do cloud? Can we do something on AI with some other partner, right? That's not the case anymore. Even the customers are seeing the benefit of having an end-to-end engineering experience, which is what we are actually seeing in the industry by having all the verticals plus semicon as a horizontal.
Excellent. Thank you so much, Gilroy. My next section will be a little bit more focused on depth and detail. And what I'd like to do is, my first question is on some of the new trends and innovation. And I think, Dilip, you kind of covered that in your opening commentary. So I'll kind of direct this question to Steve right now and try and get, Steve, your opinion in terms of what are some of the new disruptive changes that we have seen, especially from an engineering and R&D context, during the course of this pandemic? And which of these trends do you think are going to be sustained in the short to medium term as we move out of this pandemic situation and look at the future of the semicon industry and how semicon industry will influence some of these new innovations in different consumer industries as well?
Well, I think some of the more interesting innovations are really around the packaging level. Engineers can be pretty creative. If for years we depended on Moore's law, and more importantly, Dennard scaling. In terms of every time there was a process generation improvement, you saw an improvement in performance and improvement in energy efficiency as well as cost. About 2005, we started to recognize that the improvements in energy and performance, even though we were getting a commensurate improvement in number of transistors, number of devices, that continued. The improvement in terms of energy and power was starting to wane. And so there was motivation from the industry to start looking at, what call them heterogeneous architectures. I still contend that even though a CPU hides behind an instruction set, it was heterogeneous underneath because there were different units that were used to optimize those instructions. But there was really more of a focus in terms of actually having to change the programming model to be able to handle, different types of computation. And it really becomes more of, a packaging issue. Now you get to the point where, you can put 80 billion transistors, 100 billion transistors in a particular device or particular package, but there are routability concerns, power concerns, memory bandwidth. This is, where a lot of the work that we come into play. Memory bandwidth tends to be a challenge. And, even though you're adding more and more compute capability, you need to make sure that the rest of the system has balance. so that your applications and your problem set actually can take advantage of that greater compute. It's just not, having something that can, drive at 180 miles an hour, but you're in a 25 mile an hour times, speed limit and can't get better. So I think packaging has been a pretty innovative solution that we've seen going forward. I still see semiconductor improvements continuing at least for the next decade, and how we put those together and make energy efficient, cost efficient, scalable solutions is, a tremendous engineering opportunity. And as I've said, when engineers are presented with a challenge, they come up with solutions that are extremely creative and innovative that you may not have thought if you continue down a particular trend. One technology that we've been focusing on a lot is AI, and not necessarily because it, in a big way, it does create a significant opportunity in terms of optimized memory and storage solutions to make AI better, but how we can actually use it for, more everyday, not necessarily how can you use AI to understand people's buying trends, or how can you use AI to, find, create text. Those are all really important. But how we use AI just to do our normal day-to-day, just average everyday types of things that occur that people don't know about. The amount of complexity we put into our devices to make sure that we can compensate for errors, whether they're just, traditional radiation strikes that happen to flip a bit, which can cause a problem. And as we push performance higher, the cost of doing that using traditional techniques is getting more and more expensive. However, with AI, we can improve that performance and reduce the cost and complexity by at least an order of magnitude. And that's just in everyday management. We've been looking at how the next generation 6G baseband algorithms can benefit from having more, focus in terms of how we can use artificial neural nets to be able to do a better job of beam steering and managing the energy and modulation and demodulation and things like that. So it really is the fact that as traditional computation has kind of limited out in terms of its accuracy, with more data and with these new capabilities, we can actually apply AI to a larger portion of what we call traditional computation and get better results faster and with much less energy. And then we can move the computation closer to where that data is being stored rather than to some central location. So I think the how AI is going to evolve and just, it had its euphoria and now it's just going to grow into a steady build out. We're going to see a lot more of what we call traditional AI in just general purpose everyday things. And we need to get in front of that and make sure that we can build secure and robust solutions so that we're not creating yet other problems down the road.
Interesting. Thank you so much, Steve. That was a very comprehensive and clear answer in terms of what are the different things that we are going to be seeing. Mustafa, I would like to come to you, right? And this question is related to almost what you touched upon when we started in your opening commentary, and that's around vertical integration. And you being part of Microsoft, I'm sure you understand this a lot more than many of the overall industry level. Why do you think semiconductor is becoming so important that, the likes of Microsoft and Google and Meta and so many of these other companies are significantly investing in this? And what are the challenges that you foresee, right? Is it as straightforward as just putting a few people and getting the development and R&D in the space? Or what are the key challenges that you are seeing in this space?
Thanks. And honestly, I'm technically more curious to kind of talk about packaging versus chiplets with Steve. So I'll kind of park that aside and maybe we can talk about that later. But, like I said, this is nothing new that is starting from scratch. If you just look at the challenges and the stack that companies feel they need to create out in the future and what's available, and where do you think you can get out to via a partnership? And where do you see there's a natural opportunity for technical differentiation? And that's where people want to kind of go develop their own IP. Now, there's also a company, I would say like DNA or culture on how they go about things. Some companies naturally are tuned to doing a lot more themselves and saying, hey, we'd rather have the end-to-end experience and stack and delivery. And there are some companies which have more of a partner or ecosystem first mindset that we really sort of work with others. And it may be a little bit more slower, a little bit more painful to get there, but there's power in the ecosystem and partnership, right? So that also kind of plays a factor. I'm not going to name any names from the list that you said. I'll let it for the audience here to figure out who might match where. But I will say Microsoft is a lot more in the partnership side, just from our perspective. So we continue to partner with the entire hardware ecosystem, from silicon to IP to components, OEMs, and really work through that entire chain in making things work. Back touching on a few of Steve's points, right? I sit more on the data center side of our business. And if you look out into the future, the infrastructure that needs to be created to support these ginormous data sets and AI algorithms, it needs to fundamentally be different, right? Like the compute capacity available in the cloud, how do you move data back and forth? Right now, because a lot of early cloud has been built using parts not really designed for this, you keep finding chokeholds. You can get more compute and data at the node, but now you're choked at the top of rack switch, and you can clean that out, and then you're going to find a chokehold someplace else. So I think there's a big system level redesign opportunity, and we're having discussions with our partners on what the future looks like, and it will require innovation across the stack. And I can kind of keep going on there, but I just want to touch on the last point of your comment. The appreciation to me is I sat in the semiconductor industry where software was thought to be easy, and it's really the hardware that is the difficult part. And then I came to a company where by and large people feel it's really the software that is hard and hardware is the easier path. So I've sort of seen both sides of it. You can't dilly-dally if anyone wants to go into semiconductor design, especially leading-edge semiconductor design. Companies need to be very, very thoughtful of what they are getting into. If you put a few people in a little bit of a side project, you can develop some interesting IP, but you're not going to have anything like a roadmap. And some of the companies that now have pretty robust semiconductor portfolios, but did not really were seen as semiconductor companies 15, 20 years ago. They are some of the largest semi-design houses now, right? So they've put in a lot of effort in this area. So do not take it
Interesting.
That's been my internal advice to people who do not have a semiconductor background in Microsoft.
Interesting, Mustafa. I think this is almost a perfect segue to the question I had for Dilip, right? So Dilip, we've seen, even like Mustafa said, even companies with deep pockets like Microsoft and very traditional high spending R&D background, not finding it as easy as we would imagine to, develop IP and new innovate on this semiconductor side. From your perspective, and you've been part of the core manufacturing space, you've been part of the traditional GE spaces, industrial, and now definitely part of the healthcare space. How easy or difficult do you see for a company in the traditional manufacturing and the healthcare space to start investing to create your own chipsets, etc.? What are the challenges that you foresee, or do you think it's easier because they know how to do capex heavy work? So I just wanted your perspective on this very interesting problem statement.
The famous words, the unmute. Well, I think if you think about some of the industries, take it healthcare or some of the industrial segments, unless the volume drives, the game of managing the investment, moving into that chipset is going to be very challenging. The volumes in these kind of setups, we're all high value, low volume players. If you think about it, like an MRI costs millions of dollars, but we don't sell them in millions. We sell them in maybe thousands or something. So it always becomes a challenge to really get into the investment levels to really make it work, your own chipset levels and all that. You need to always look at partnership models here to really bring in that scale. We may have to work with similar industry or other areas to make that happen. But to do it on your own is a challenge. Of course, there will be a few cases where you need to do it, but on a larger level, it is a challenge on these devices.
Excellent. Thank you, Dilip. Gilroy, again, always can depend on you to round this. And I have another interesting question, which I think even the audience alluded to. Firstly, you have seen, and I'm sure you have witnessed the struggle firsthand across different types of companies, the non-traditional semicon companies trying to develop their own IP, etc. So if you could talk through that, that will be interesting. And at the same time, one of the aspects I want you to also touch upon is, while the industry says that there is shortage of digital talent, I'm sure there is, the VLSI engineers are almost like gold right now. So how do you even build talent and try to deploy them at scale to help solve the customer silicon problems? So if you could answer both of them, it will be perfect.
Absolutely. Yeah. So both are very interesting questions, right? So the first one, I completely agree. I think more and more technology companies and even the consumer market companies are also looking at making their own silicon chips. So again, the way we see it from a services standpoint is three things. One, why they didn't do it earlier, primarily because the processing power has gone up exponentially for the chipset, right? So now you have AI on edge. I think that is one of the huge tools that they have. I mean, earlier it was not the case. I mean, I was talking about computer vision earlier. Now, most of the applications that we implement as solution for any vertical, computer vision is an element. And how is that possible? It is because AI on edge. So that is one part. Secondly, I know a lot of companies adopted cloud, but now that is also a costly affair, right? I mean, everyone talking about cloud, I mean, it's also coming with a cost. So how do you balance that? And that is where those companies who can actually balance and be smart in leveraging a hybrid model of cloud with edge makes a huge difference. And that is another thing that we are seeing significantly. And third, it's very interesting. I know Dilip mentioned about high value, low volume. It is absolutely true. But at the same time, how that can be enabled is also the fabulous semiconductors that are available now, right? You do the design, you work with some of the TSMCs and global foundries of the world, you can still get things done through foundries. So all those three things are the things that we hear from the customers when they talk about, okay, why they're going about all these aspects of their own chipsets and silicon chipsets. Now, coming to the second point that you mentioned, I mean, it's not easy. I mean, VLSI, if you have people, I mean, you have demand the next minute. Now, what a lot of companies are doing is they're changing the model of outsourcing. Gone are the days when you say, can you actually build a team of 20 people with all of them like 10 years experience and so on and so forth. There is a lot more acceptance and adaptability to outcome-based models. You call it managed services or outcome, or even lead-led models, which are like, again, maybe it's a phenomenon of COVID. The customers are also ready to do that. And the lead-led model is definitely enabling that. And on top of that, how do you sustain all these things going on with shortage of talent? Every company is investing on top-notch educational institutions at earlier years of completion, in the sense second year or third year of completion, to make sure that the services companies tie up with them in coming up with different models. We call it finishing school model or the joint curriculum model. There are so many models that are available today, which is also enabling, because VLSI, you can't actually do it with just a graduate, right? So all those kind of models are being adopted. And secondly, there are also trends that we could see with global customers, especially the large firms, where they're enabling the geo-presence scale. So if there are shortages in one country, why not you scale in another country for certain projects, especially in high demand? And we are enabling that too. So these are some of the things that we are seeing, Siddharth.
Interesting. So you mentioned training, you mentioned, tapping into different talent catchment areas across the geographies. Interesting. That's a good way of doing it. Mustafa, I had a very similar question for you, right? And again, the reason I want to direct this to you is because I think Microsoft is recognized as almost the foremost when it comes to managing to hire people, retain them, good HR policies, different things that Microsoft can enable to get the best talent. Do you think it's easier for somebody like Microsoft to build these sophisticated silicon teams, and the one that you just mentioned right now? And also, what is it that you would advise in terms of some of the best practices in hiring and retaining this kind of high demand talent or talent in high demand?
No, I don't think it's easier for us. We all face a very competitive landscape, and people have more choices, especially with this COVID and virtual work area. A lot of people are feeling disconnected from the enterprises and their missions, and connection and purpose is very important for people on why they choose to be where they are. So I think Microsoft certainly is working on tools and technologies from our overall portfolio to help foster that. We are experimenting on a lot of things, and we're putting some of the research out there, but it's easier said than done. What I do see, I see AI playing a role here too, right? So if you look at the software development, to deal with some of the workforce constraints, software development keeps moving to higher levels of abstraction. And so model-based development or abstract-based development, I think, will develop in the silicon space as well. And so technology will have to come to bear to address some of the design engineering shortage. Another thing I want to call out is this is not lost on governments as well. We are working with the government on securing this supply chain for semiconductor design manufacturing. And one of the areas we're talking about is how to kind of foster more workforce development efforts. We have done something with TSMC in Taiwan for workforce development. I know there are efforts in other countries as well. And because we have a global backbone from our cloud, we can be a local partner for those countries.
Interesting, Mustafa. I'm actually very tempted to go to Steve. Steve, you've been in this industry for so long, right? And been doing, silicon development. You've seen it across Intel. You're doing it at Micron. And Mustafa touched upon maybe one or two innovative ideas to overcome the talent shortage. Steve, in your mind, do you think there is something that can be done, like take engineers out of a different field, train them very quickly through some module that you can put together, or maybe use technology to kind of fill the gap in what they really understand from an experience? How do you accelerate this learning? How do you bring engineers to be productive much faster? Because I don't think we can wait for universities to churn out another 10,000 engineers that will come out after 5 years, right? So any interesting ideas that you might have, because it's a big problem that we're all facing.
Well, it is a big problem. I agree with Mustafa. I think we're going to have to use technology as much as possible and get to the point where, because the one of the problems I'm seeing by that is, as people, for example, is some of the newer engineers that we have in our organization are developing simulation models. They tend to trust the model without really understanding the underlying assumptions behind it. And, I've got the fortune of having, been around so long that when they show me something, that doesn't look right. And, when I started, I was just thinking about it. This was our design. This was our EDA tool, a nice pencil. And but you came out with a good fundamental understanding of the engineering laws that that dictate our industry that are now all handled, basically electronically. One of the challenges we've always had is how do we, get people excited about being in the industry, and I don't think it's really a money thing. I mean, I'll never forget when, back around the turn of the century when young kids were developing, a computer game or something like that, and they were becoming multimillionaires, at the age of 25 or 30. And it got to be, how do I get to that point where I can do something where I would really enjoy life? So I think, it's important to develop a new cadre of engineers and continue to develop the workforce. But we have to make it something where, when as younger individuals are getting involved, that they want to be there and really enjoy it. And I don't know if you can take, it'd be interesting to hear what Mustafa thinks, but for years, it seemed like hardware engineers and software engineers just came from different planets. They worked at different hours and they looked at problems in a different way. Now, over the years, we've had to combine the two, but still, it's, I don't know if you can take somebody from an engineer from another industry and say, okay, we're going to retrain you and you're going to be a good computer or electrical engineer, because sometimes there's just sometimes the thinking's a little different. So I think technology, we're going to have to leverage completely, and we're going to have to put the fun back into this work.
Interesting, Steve.
I just add a point on that.
Go on, Mustafa.
So I agree, like software and hardware engineers still are on completely different planes from what I understand. And I think technology can potentially help. Hardware design still is at a much lower level of abstraction than where software design has moved up to. So I believe if we can help hardware design move up the abstraction curve, then maybe technology can help decipher where that should get laid out. I know it's not going to happen anytime soon, but it's something that just like you mentioned, the slowdown in Dennard scaling and Moore's law forced us to look at alternatives. I believe the challenges we have to tackle across the hardware-software boundary will force us to look at alternatives down the road.
That's right. I totally agree.
Interesting, Mustafa. Dilip, I have to bring you in, right? One is the talent-related concern. One of the things that we believe is possible is to look at partnerships, and I think Mustafa touched upon it. Partnerships across the value chain. It could be startups, it could be other companies, it could be service providers. How important do you think that is? And also, what are the key challenges maybe in kind of working through these partnerships? Where are the areas that you think the ecosystem needs to step up? I really wanted your thoughts on this.
So look, I think if you look at healthcare industry, for healthcare industry to reach its pinnacle goal of, making wellness matter, not the illness, right? I think today everyone earns out of illness. I think in the future, everyone has to make money out of wellness of somebody. I think to move towards that goal, it is not one company that can make it happen. It is only possible when there are many companies that are going to come together. Whether it is startups or an industry which is dealing with data on, let's say, automobiles or data on something else, every data has to come together. And one of the challenges that we have today, if I want to just take the example of, let me make imaging a lot more smart. When I say imaging a lot more smart, take the skill out of it, bring in intelligence into it, bring in acumen into it, so that anyone sitting there can make a decision better. To do that itself, I think it needs a lot of data to be trained, and a lot of data that needs to be structured in a way that could be understood. AI models need to be created. And today, unfortunately, the data that is available globally, there is no structured way or a standard way of structuring. Everyone does. Everyone does their own way of annotating. Then anonymization is a big deal, because you can't really bring in name of the patient into any of the thing that we deal with. So how do you bring in the data that is going to be anonymized, annotated in a right way, so that the learning that the AI models get to make it accurate is a real challenge still. But it's working well. I think there are certain models which are, starting from startups to large companies have created all that. But I call it still as a bits and pieces solution yet. It is not still a complete solution for a human being. We need to look at one at a disease level, which I call it as a horizontal. Cancer today, we are very good at it. If you look at Siemens, we have with a Varian, we have a solution which can manage everything, early detection and all that. Look at stroke, look at cardiovascular diseases, and if you look at those things, you hear of people dropping dead just morning he was okay and afternoon he is not there. There are telltale signs somewhere, but no one notices that. How do you get those signs? And how do you convert that into a treatment that can be done early enough, right? To do that, we need to coordinate and partner with a lot of other companies. Like if Siemens is today focusing on the horizontal disease levels. Siemens is focusing on creating digital twins. Now, to make this successful, partnership is the only way. Smartest people are sitting in startups, bring in their solutions and integrate. Smart guys are doing these smart watches. It is continuously telling you what's your SpO2 level, what's your heart rate, what's happening with, other day when I was walking in the night, I tripped and fell down. Immediately my watch said, did you fall down? Shall I call an emergency number? I mean, how do you utilize that to continuously create that? So to me, it's a challenging thing, but the only way to make human health better or wellness as a future goal is the partnership model. It is difficult. It is not easy.
Right.
Because at the end of the day, think about it. Who pays for everything on healthcare is the patient. Right. And patient doesn't want to pay 1 rupee more for any treatment that you give. So that is the money that needs to be divided by all the partners. But today, many times when we create an AI-based solution, we expect that we want to be earning a lot more money on that. It has to create efficiency. It has to create.
So it's conundrum. Always a conundrum of new technology versus
exactly.
Interesting. So I'm just running out of time, and Gilroy, I'll let you have the the final question, almost the same question that we discussed, but I'm sure because of your perspective from across different industries, could you please share some good examples as to how partnerships can really work, right? So we discussed how it's very challenging. Dilip really mentioned about it, and Mustafa did too. But what are the things that, just 1 or 2 examples of how it can really work in terms of a good partnership?
So there are 2 use cases that I can talk about, right? One is the frictionless commerce that I spoke about. It's called walk in, walk out, right? So as the components, there are multiple of them, whether it is the vision checkout, where you're just using video analytics. It is done by a startup company. So we actually partnered with them and they brought in that element of things, right? Then there is another thing that actually manages the temperature control of a cold storage inside the retail. That is using a sensor-based technology called Cold Truth. So we actually had another partner. So it's a combination of partner companies or startup companies, which actually is getting into cutting-edge solutions. And we are always looking out for those people to get things so that we can get speed to market in a much faster way, right? So now that being one element, let me go into the IoT 5G story. So when we did the frictionless commerce, we figured that, okay, we can actually create a autonomous store for any retailer. Now, when it comes into an automotive customer or a telecom customer, we could actually bring in the IoT 5G at the multi-edge access point or access computing level, or edge computing level. So that mech sits on the edge of a tower of a telecom. How did we actually enable that? I mean, we didn't have all the technology to really get an NB-IoT mech solution for this. We actually created a partnership model on an ecosystem model with some of the startup companies who could bring in those elements of things. For sensors, we had to bring in another partner who actually integrates with the cloud infrastructure. And then there was another thing on the sensor weighing machines, which actually weighs certain things that actually goes into any of the data centers. So there are so many elements that came into the IoT solution that we had to actually create, where we had to go out and fetch for. Now, second thing that we also did is we created something called Garage Ventures, which is an initiative that UST has initiated, where we wanted people to come up with ideas, and we will enable them to do we'll do the funding for them. And that also brought in quite a few startup companies enabled by UST in the last 4 years. And we also do a annual event to appreciate and reward some of those best solutions. And then we take it to our customers too. So all of these things has enabled us to come up with these two solutions that I spoke about: frictionless commerce and the IoT 5G on Mac.
Interesting. Thank you so much, Gilroy. And thank you all the panelists. I'll hand it over to Natalia to sum up our discussion and close the session.